The universe was born to die, but how and when will it all end?
That's the reason I became a cosmologist. I wanted to be the first person that would know how the universe would end.
Two cosmic heavyweights wrestle for control. The winner seals our fate.
That tug of war is gravity, which is trying to shrink it down, and the expansion of space and time itself.
Will gravity triumph?
The universe will get smaller and smaller, hotter and hotter.
Or will expansion get the upper hand?
Even the electrons around your atoms will be ripped apart.
The end is coming, and it could be sooner than you think. The universe is everything. All space, all time, all matter. The Earth is a speck by comparison, a grain of rock orbiting just one of the 200 billion stars in our home galaxy, the Milky Way. In turn, this enormous structure is just a drop in an ocean of galaxies that stretch for 90 billion light years. And all of this, from the biggest galaxy to the smallest atom, will one day die.
We don't see evidence of anything being eternal. Eternity doesn't exist. Even space and time will come to an end.
The universe has been expanding since its birth, gradually burning through the fuel that lights its stars. But what happens when the fuel runs out? Will it all just fade away?
Stars die out, use up their nuclear fuel. We have an empty, cold, desolate universe.
Just dead remnants of stars, black holes, neutron stars. Eventually they decay away, and you're left with a thin haze of very low energy light. That's it.
We used to think the universe would cruise gently into old age. But over the past few decades, astronomers have revealed a very different and disturbing picture. The universe isn't cruising, it's fighting for its life.
It may seem peaceful here on Earth on a nice sunny day, but in fact, above us and all around us, throughout the universe, a battle is raging, and it has raged since the beginning of time.
Two deadly forces grapple for control. The first, expansion, pulls galaxies apart, cooling the universe and threatening it with a frozen extinction. The second, gravity, tries to crush everything back together, annihilating the universe in a dense ball of fire. Will gravity or expansion win? Or will it end in a tie? These two colossal forces yield three endgames.
One is the big freeze. Expansion wins, and the universe just expands forever. The second is that there's a delicate balance between the expansion and the amount of gravitational attraction, and the universe gets to a particular size and it pretty much stays there. And the third outcome is that the gravitational attraction wins and the expansion stops and the universe begins to get smaller until eventually it goes back to a big crunch.
So far, the universe seems balanced on a tightrope between expansion and contraction. But will it keep its equilibrium until it runs out of steam? Or will something tip the balance?
I don't think there's any bigger question than where is the universe going?
To predict the future, cosmologists have always looked to the past. Back to the beginning of expansion, the beginning of gravity, the beginning of everything. 13.8 billion years ago, an infinitely dense hot speck ignites and suddenly expands outward. The Big Bang. All energy, all space, and all matter. The building blocks of the universe we see today are created and set in motion.
Think of it. everything you see around us concentrated into a primordial fireball that exploded, sending all the galaxies into motion.
That outward blast, the birth of expansion, is still going on today. Without it, we wouldn't have a universe big enough for stars and galaxies to exist in. Expansion is an astonishing force of nature. It works by inflating the fabric of space-time.
Space between galaxies expands, and it pushes the galaxies apart.
Space carries objects with it, like a surfer on a wave.
It's going on in every part of space. Even inside your body right now, there's a pressure for space to expand.
Expansion generated the vast moving stage on which today's universe plays out. But left unchecked, it could have been a force for utter annihilation.
If the universe had been expanding much faster, it would have emptied out so fast you wouldn't have had time to make galaxies, planets, people.
The fact we're here means that something must have put on the brakes. It was, of course, our universal glue, gravity. Gravity and matter go hand in hand. The more massive the object, the more pull it exerts on everything around it. It draws atom to atom, particle to particle, building stars, nebulae, galaxies, the hardware of the universe we see today. But gravity is a double-edged sword. Too much, and the early universe would never have gotten out of the starting blocks.
If it had been expanding more slowly, it would have recollapsed into another singularity, and again, you wouldn't have had the time to make galaxies, planets, or people. So we live in the Goldilocks universe. We live in the universe that lasts long enough that we can be here, but expands gently enough that we have time to form.
The universe has lasted for 13.8 billion years, thanks to the opposing forces of gravity and expansion. But how stable is this balancing act? Does our universe have just the right amount of stuff to keep it from runaway expansion or catastrophic collapse? In the 1920s, scientists did the math, and the results were anything but reassuring.
The more matter you have, the more gravity you have. If you have lots of matter in a very dense universe, perhaps the universe begins to recollapse. Or if you have very little matter, the universe would freeze to death. So what is the critical density, the border between the two? It's approximately 5 hydrogen atoms per cubic meter. So think of a cubic yard and put just 5 hydrogen atoms inside. And that is the tipping point. If you put more than 5 atoms, then the universe will begin to collapse. If you have less than 5 atoms, then the universe just keeps on going.
If we'd thought the universe was balanced on a tightrope before, the critical density question showed us the rope was a razor blade. Yet when astronomers took additional measurements, they liked what they saw. The universe appeared to contain just the right amount of matter to stay at the critical density.
More and more, the indirect evidence and the theoretical arguments suggested that the universe must be exactly at the boundary between a universe that would collapse and one that would expand forever, that we were teetering on the hairy edge of expansion.
The universe is balanced on a tightrope. On each side of the drop lies an early death, a big freeze fueled by the runaway stretching of space, or a big crunch, the result of gravity overcoming expansion. 40 years ago, scientists believed we'd stay balanced between these fates for eternity.
Now things have changed tremendously because we've discovered something we never knew about 40 years ago.